Okay, so first we're going to talk about what are the tools that the web environment provides us, developers, to write animations. What are the, how can you can write animations using CSS or JavaScript or maybe a library. Then we are going to talk about how to debug animations and how to write performance animations. And last but not least, we're going to talk about what are the components that we offer us for writing transitions or animations. And finally, we will end up with a short demo about a Vue demo project. We will try to animate a simple component that I wrote this week. Okay, so why I think animating the web is important? Well, when the web was built, it was built as a way for sharing documents. This legacy web, you just clicked a link and you went to another document. There were no, it wasn't meant to create applications. It was just to share information, to share data, documents, but as it started evolving and in CSS, JavaScript, developer realized that we could use this platform to build really powerful applications. And this is where I think things start getting quite interesting. Because when you are building an application, in your mobiles, when, for example, when you click things, the state of the application changes. Just a certain part of the state changes, and probably you want to reflect that in the UI of your application. So animating these changes, you are essentially making your application more understandable to the user. You are not suddenly changing all the layouts around and making your user lost the focus on what were they doing or what they were trying to find. Well, let's start. How can we animate things? The most simple way to animate something, for me at least, is using CSS. For example, we can use the transition property. I'm sure most of you already know this property. Basically, it interpolates to simple values. You define the property that you want to animate. For example, you could animate the size or the color of some DOM element. You can also set how long will this animation last. And or if you want this animation to be played after a couple of seconds using the delay property. And the last thing that you can configure using this transition property is the easing, which is a really important part of the animations for me. And with the easing functions, you are essentially defining the acceleration of your animations. I love to use this tool, Caesar. I don't know how it's pronounced, but essentially with this line, you're visualizing the acceleration of your animation. So in this case, it's linear. It's just things are just going to happen as defined speed. You can click some of the example transitions that they have here. You can see it doesn't accelerate, and this doesn't feel very natural. So probably you would want to use something like ease out, where it starts faster and then it slows down. This feels more natural for living transitions, or I don't know, maybe the ease out back. This is not a standard CSS transitions, but you can build it using the cubic Bezier CSS utility. This is CSS code that you can copy and paste in your projects. And you can see with this transition how it kind of goes a little bit farther than the element should go, and then it bounces back. And so these functions are for me are really important, essentially to make transitions feel more natural, feel more organic, maybe. Another option that you can use to animate things is the animation property, as its name suggests. This is a little bit more complex than the transition because you define several steps of the animation. This is great if you want to make something more complex. Things like first, if you have a box on the top left corner of the screen and you want it to move to the top right corner and then to the bottom right corner, then to the bottom left corner, and then back again to the top left corner. You could define this using this property. Like the transition, you can configure the properties that you want to animate, but instead of doing it through an option in the animation property, you set that using the keyframes block. There you define the name of the animation, and for each step, the step is just the percentage of the animation, like 0% apply the CSS, 50% apply the CSS, and 100% apply these styles. Then like the transition, you can define the duration, the async function, the delay of the animation. But it has also some really interesting properties like the iteration count, which can be used to say, hey, play this animation like 2, 3, 4 times, or keep it playing infinitely. With the direction, you can reverse an animation. This means that if you write, for example, an animation using this keyframes object that simply moves one element from the left to the right of the screen, and then you want to move it back to from the right to the left side, you just have to set the direction to be reversed. With the fill mode property, what you define is if the styles that you are applying inside the keyframe object, if the initial or the ending styles are going to be kept. You would do that, for example, with setting the fill mode to the forward option. And finally, with the play state, it's just a utility group to play or pause the animation. It doesn't do anything else. Another option that we have, if we start talking about JavaScript animate things, is using the request animation frame. This is a JavaScript function that essentially will invoke the callback that you provide to it. And inside this callback, you will run your style changes. You will update DOM elements with the styles you want. This callback will be invoked just before the browser is about to render a frame. You know, browsers work more or less like films or video games. They render images really fast into your screen. And so every time the browser is about to render one of these frames, this callback will be invoked. This request animation frame can be really helpful if you want to run long-lasting animations and you want to have a very granular control of what is happening at each frame. Probably in that case, you are going to write a recursive function. So inside this callback, you will invoke again the request animation frame, and at some time you will have to stop it. So be careful and provide a proper stopping condition if you don't want your browser to hang. And finally, we have, talking about vanilla CSS or JavaScript, we have a new API. I think this was released out of the experimental tools like 6 months ago or something like that. So it's quite new. It's still a work in progress. They are still improving this API. This new API is essentially similar to the CSS animation property that we just showed a couple of seconds ago. And what you do here is you select an element, a DOM element, and when you invoke the animate function over it, you have to provide with some keyframes like you did with the steps in the animation CSS property. In these keyframes, you modify the styles of your element. You can set things like changing the color or the position or the size of this element. And you also have to provide a timing options object where you configure things like the duration of the animation, the delay, or the async function. This is quite new, and honestly, I haven't used it yet, but it looks like a really promising API. And this was the last of the vanilla options that we have on the web. These are pretty basic and pretty low level. So if you want to build really complex animations and animation-heavy websites, you would probably like to use a library. GSAP is the most popular library for building animations, both for DOM elements and SVGs. This The problem with this library is that it's really huge. It's massive because it has lots of options, trust me. So if you only want to add some simple transitions to your website, it doesn't make sense to use it. Where GSAP shines is when you want to write complex timelines and do a complex orchestration of the animations. Some of the options that it has, you can write simple interpolations using really custom easing functions, not just the ease in, ease out that we saw with CSS. The way it makes you write the code of your timelines, it's really maintainable. So if you write, for example, a really complex animation using only CSS, you will notice that when you have to modify that animation in the future, I think that will happen for sure, it will be really hard. The code you write with the native CSS animation property is not really maintainable. So this is something that this library solves. And another thing that is really cool about this library is that it has some hacks, if we want to call them like that, to make the animations work well in every scenario, in every browser. Because unfortunately, we have to support browsers that are not as modern as Chrome could be. And here, well, I like to give you some small tips, some basic tips about animation, something I wish that somebody told me when I started becoming a front-end developer. Apart from basic things like apply the animations immediately and don't make animations last for a long time, because it will make your site look slow. As I told you before, for me it's really important to use a great easing function. Because as I said before, if you don't accelerate your animations, if you don't provide an acceleration using an ease function, animations are going to look very robotic, I would say. Things in real life tend to happen smooth and slowly. When you accelerate your car, it doesn't go from 0 to 10 in kilometers per hour immediately. It takes some time to happen. Another thing that which someone told me when I started animating is that don't try to animate everything. If you animate everything in a website, there's going to be a chaos. You have to try to orchestrate these animations, and maybe some elements can't be animated, or you shouldn't animate when they change their state, and you should just let things happen. Another thing about animations, you can animate lots of properties. You can animate color. You even have now APIs to animate 3D. Well, making 2D elements look like if they were 3D. I don't know, you can have filters that make your content blurry, or I don't know, change color, or saturating them more. The more things you add, probably your animation is going to look uglier. Usually, simple transitions like fading an element or just moving it a little bit are the ones that usually work best. So, well, now we know some things about animations, how we can animate on the web, but we should be aware when we are writing animations about the performance and the cost it has to write an animation. Fortunately, browsers has a really great tool set to help us understand what is happening in each moment of our animations. Before I show you these tools, I want you to understand how the browser and rendering pipeline works. The browser essentially draws frames, draws plain 2D images. But to compute these 2D images from the things that you provide him from your source code, which is basically HTML and CSS, it has to run several steps. The first step that it does to create these 2D images is it has to figure out which CSS rules that you wrote apply to which DOM nodes. This is the first phase, the style phase. Once he knows that, he can apply the layout styles. The layout styles are just related to the positioning and the size of elements. Things like the height, the padding, the margin, the borders are computed here. Here, it still doesn't have images. It just knows where each element fits inside the website. Then, with this information, it can start painting with the pending CSS rules. And here, it paints each element separately. It's a DOM node that you write in your code. It's its div, its section, its anchor element is painted independently. And here, yeah, it applies the rest of the styles, the colors, the backgrounds, all that kind of stuff. Once it has these separate images, it has to compose them. Because things can, in the website, you can have one element that is near each other, or elements can be on top of each other, overlapping a little bit. So this is what happens in the composite phase. I wanted to show you this because when you're animating, this pipeline has to happen really fast, has to happen at least at 60 frames per second. The browser essentially has 60 milliseconds to do all of this work, and trust me, it's a very expensive work. So if you want your animation to look smooth, to not look janky and laggy, you should time to make this work in less than 60 milliseconds, which is 60 frames per second. You have different CSS properties, and depending on which CSS properties you use in your animations, different phases of the pipeline are going to be triggered. For example, if you animate the size of an element, like using the height or the width or the padding properties, this will trigger the layout phase. So the browser has to first figure out the new layout of the web, because even if you are changing the size of a single element, this can affect the rest of the elements of the website. So then first it has to figure out the new layout, then it has to paint again the new elements, and finally it has to compose all these layers together. Other properties like transform or opacity only trigger the composite phase, because they doesn't trigger the layout phase. They don't change the geometry of the object, and neither the aspect, how they look. And they just move things around. So transform or opacity are properties that are very cheap to compute. And other properties, for example, like filter and backdrop filter, which trigger the paint phase, should be more performant than the ones that trigger the layout phase, but they still have a cost. So, for example, if you are using a blur animation, a blur filter, this is very expensive to compute for your computers. So even if the browser isn't executing this layout phase, you could still run into performance problems. It's really hard to figure sometimes out which properties trigger which phases. So there is this cool website that I wanted to show you. It's called CSS Triggers. And here, essentially, you have a list of CSS properties and which phases of the rendering pipeline they trigger. So, for example, if we search for the transform one, you could see a small explanation that, as I told you, it doesn't change the geometry or painting. And that's a good thing, and it only triggers the compositor thread. It also gives information about which phases each browser works differently. So it tells you how this pipeline is going to be affected in each one of the browsers. Then, for example, would be Chrome, the most popular web browser. Gecko would be Mozilla. Here we have WebKit, that will be Safari. And we have I think, legacy right now, the old Microsoft Edge browser. So when you're running into performance problems with your animations, maybe this is a good point to start figuring out if you are using expensive properties. Okay, then I don't know, you're a lot, probably you're not going to answer my question, but I have here two different functions. One of them changes the size of each element of a list. It changes to be a half of the previous width. And it does so using just a single loop, a single for each loop. And the other one does this using two loops. First, it retrieves all the bounds and then it modifies the size of each one of the elements. First, it does the reach operation, and then it does the write ones. While the first one does it all at once in a single loop. So probably most people would say that the first snippet code is faster. Let's check what happens when we run this code. I created this small code pen to visualize it. Here, well, I have the code that I showed you before, plus a simple function to measure how much time it takes to execute this code. If I modify the sizes of this list of elements, I think there are like 1,000 elements. Using a single loop, it's going to take over half a second. This isn't good. As I told you, we are not talking here about animations especially, but this also applies for animations. Whenever the user makes a change to the website, you should expect things to happen in less than 60 milliseconds, almost immediately. And here it's taking over a half a second. It's a long time. But if we halve the sizes using the 2 loops, it takes just 6 milliseconds. You may be asking yourselves now, why does this happen? This goes against common sense. Okay, the browsers are clever and they try to optimize things. One of these optimizations is that when you are modifying the styles through JavaScript, the browser does not re-render immediately. It tries to group these changes into a single re-rendering pipeline. But if you ask the browser to compute some dimensions, like we are doing with the getBoundingClientRect function here, there are other properties like offset height or inner height that will also ask the browser for dimension-related stuff. When you ask the browser for these things, it says, hey, I still have some CSS changes pending to apply. Let me re-render, and I will tell you the value that you asked me before. So in this loop, because we are first modifying an element, the next element that is going to be modified is going to make the browser compute the styles for the previous one. It's going to essentially trigger a re-render for every single element that we have in this list of nodes. Does this make sense for you? I don't know if I'm going quite fast. This is quite hard to figure out the first time, at least. So if you have any questions, just ask me if you don't understand something. With the second function, what we are doing is we are batching the reads and write. We first make all the measures that we need. At most, the browser would do just once for rendering here, and then we modify all of the nodes at once in a single loop, but without asking the browser for new dimensions. So with this function, we are just making the browser re-render at most maybe 2 times, instead of potentially making it re-render 1,000 times in the first function. When you're writing animations, this is really, really important to take care. As I told you, you should aim for the 60 milliseconds mark. And last, we have this property, this will change property. It's a CSS property that you can use to give a small hint to the browser of things that are going to change. And then the browser may or may not listen to these hints. The problem with this property is that it creates a new stacking context. It creates a new layer for the element that you apply this property. And this can conflict with your CSS styles. This can be an optimization technique when you know that the performance problems that you are having are related or could be solved having a separate layer for the nodes that you are animating. Usually browsers are clever enough and you don't need this function. Indeed, I think that I only had to use this function once or twice in these past 3 years. So now, how can you spot the problem? Yeah, I thought someone was asking. How can you spot these problems or debug them? There are several options in the DevTools. We will focus on Chrome, but other browsers have similar tools. Again, I've created a small code pen here. I'm going to open it in the debug mode. I'm going to open the DevTools panel. The first option that I'm going to show you is the rendering one. If you don't find this panel, it's here under the three dots. You have new options, and you will find the rendering here. Here you have several options. The first one is paint flashing. So this will essentially paint a green box on top of the elements that are causing that are triggering the paint phase of the browser rendering pipeline. So in this example, we are going to animate these three boxes. These are three boxes. We are going to animate the first one using margin left. We're going to animate the second one using the position absolute and the left property. And we are going to animate the last one using a transform property. And as you are seeing, the two first strategies to animate trigger a paint phase, while the last one does not. As I told you, transform are really cheap and they trigger the compositor phase, so they should be more performant than these two first ones. Okay, another option that we have, talking about the DevTools, is using the performance tab. So again, I'm going back to this example. I'm going to go to the performance tab. And I'm going to hit the record button. And I'm going to animate and check the result. That's how it doesn't take quite long. Okay. Here you have lots of information, but it is quite easy to understand. One thing that you should try to find out in this graph, even if you are talking about an inversion of if you are not, is find these red lines. These red lines usually are big performance issues. In this case, well, as I'm sharing my screen with Zoom and this is a small demo, it isn't a problem. Probably, I don't know, maybe CodePen is running some code in the background that is affecting. Then this green line is the number of frames per second that you are rendering. You should try to aim for 60 frames per second, as I told you. And if we zoom in one of these frames, here you can see the time that the browser that it took the browser to render each frame for. We can zoom in, and you can see at the end these boxes. And these boxes are essentially the rendering steps that the browser has. So, for example, we have here that the browser had to recalculate the styles. It has to perform the layout phase. Then it has to perform the paint phase. And finally, it has to compose these layers together. So maybe if you know a frame is taking like half a second to render, you can find here information about which is the phase of the rendering pipeline that is causing that thing to happen. Also, you will have the stack phrase here. So if you're running a complex animation, you will see here all the JavaScript code that triggered that animation. Okay, then another option that we have is the frame rendering stats. This is going to give us real-time information about the animation. It is again in the rendering panel, and it should be here. This is going to create this small graph here, which is going to tell us real-time information about the animations. The frames per second that the animation is running, the memory that is taking the browser to compute the animation. So this is kind of similar to the performance tab, but this is real-time information. And finally, we have the animation tab in the DevTools too, which is a great tool when you're writing complex animations and lots of things are happening at the same time. Let me show you. you're going to record the animation here. So now I can select that animation, pause it, and you can see that I'm moving the animation back and forth. So I can understand in every point of the animation what is happening. I can also maybe slow down the animation if, sorry, here. If I want to visualize this more slowly. So yeah, this is a great tool also to use. We will talk later about Vue, but these animations DevTool does not work really well with Vue because under the hood it uses set timeouts and maybe set intervals and cancels your animation. So if you try to debug Vue animations with this, there might be a great chance that it won't work. But it's something that is nice to know. And finally, well, this isn't related strictly to performance animations, but I know some of you ask me about the scroll transitions. We don't really write scrolling transitions like Apple does in our product, in the X Components product, but I know some basic things about it that I wanted to share with you. So you have essentially 3 ways to make a scroll transition happen. And the first one would be just to using the scroll position. You listen to the scroll event, and when this event is triggered, you retrieve the scroll position using maybe the scroll top property of the element. The problem with this is that you have to be careful because the scroll events can be fired more than once per each frame. They can be fired more than once per each frame the browser renders. So you want to probably just listen it once per frame. This is not This is nice because you can use the request animation frame here to solve this problem, to throttle the code of your animation. And one technique that is also used, I believe, at least it was used in Empathy's website a while ago. The website just has several videos, and with the scroll position, you just change the playtime of that video. So when you have the scroll half the page, the video was in its half position. You were in the middle of the timeline of that video. You just modify the timestamp of that video. Another option that you have, if you just want to animate when elements are going to enter the viewport, the screen, you can use an intersection observer. This is a quite modern API, and the way it works is basically you observe an element and you provide a callback, and the intersection observer will invoke that callback when the element is about to enter or to leave the viewport of the screen. Here in this callback, you can run your animation, maybe slating an element or changing its opacity, things like that. And finally, there is a new API proposal. This has been released 2 months ago, so no browser has implemented it yet. Maybe only Chrome in its experimental flags. I hadn't time to work with it, but it's a new CSS API to animate certain things related to the scroll position. So probably in a couple of months, or just so beyond a couple of months, we can start using it. And now let's talk about the Vue transitions. Vue is the framework that we use here at Empathy to create most of our products. The Play website is built using Vue. The X Components product, which is the one I work in, is built using Vue. So let's talk about which components Vue has to create transitions. The first one is the transition component. You can use this component to simply animate when an element is entering or leaving, appearing, let's say appearing or disappearing. And it has both CSS and JavaScript API, depending on what you want to do. You can even combine both of them. And it works really nice. I will show you in the next slide. And you can also provide with a different transition mode. The transition mode is a property that you can use when you are toggling between different elements. You can make the leaving animation of the first element to happen before the next element, the second element appears. So it's kind of like orchestrating the animations a little bit. The easiest way to work with this transition is to use its CSS API. To use it, you just have to provide a name to the transition. In this case, it's fading. And then what Vue is going to do is going to generate and apply certain CSS classes to the element that it is animating. In this case, this div. So when something changes from true to false, Vue is going to add these CSS classes. Which classes does it that? First, it has the interactive class or the leave active, depending on whether the element is entering or leaving. And this class is used across the whole transition. You can use it, for example, to set the transition properties that you want to animate, the duration, the delay, the easing, things like that. And then it also adds some function, like you can see it like animating from and animating to. In this case, I have only added the enter one. And what is going to happen here is when something changes from false to true, Vue is going to set this element to have the fade in enter class, which is going to apply immediately opacity of 0 to that element. Then it's going to remove this class. And because I'm using here this transition in the interactive class, the opacity of the element will change from 0 to 1. And in this example, I'm only talking about entering transitions, but you have exactly the same classes for the leave transitions. The only thing that changes is that instead of enter, you should write leave. Then you can also use this transition using the JavaScript API. And the JavaScript API here is pretty simple to use. Essentially, you just use standard Vue listeners that Vue will invoke within the transition whenever it should. In this case, well, I only have these enter and leave ones, but there are more. There are before enter, after enter, before leave, after leave. I think there are only these 6 ones. Inside this run enter transition function that you have to create in your component, you have to write the code that animates this element. This callbacks will receive the DOM node that you want to animate, that is entering. So here you can, maybe run a request animation frame or use the new JavaScript animations API, or just apply some styles if you want. We will see that. I have a small example at the end of the day, so we will see this. And if you want to integrate Vue with some external libraries like GSAP, for example, this is the place that you might be looking for. You can simply invoke GSAP here inside these callbacks and let him do all the heavy work for you. Finally, talking about this component, I wanted to tell you a little bit how this works under the hood. Because I think Vue's approach is quite interesting. Vue has these transitions built into its core. So Vue is a library that has a virtual DOM, just a couple of objects representing the real DOM nodes with more information that the real DOM has. Inside these virtual nodes, they have a special place for handling the transitions. And there you can find things, like the name of the transition, the hooks that we saw, the classes that it should generate, that kind of stuff. So what the transition component is doing is basically taking the nodes that you provide using the default slot and modify them, adding the information that you are adding to the transition component, the hooks, the classes, all that stuff. If you check the source code, I have linked here the source code of this component, you will realize it's a little bit more complex because it has to handle lots of edge cases. It's not as simple as that, unfortunately. There are, for example, comments or text note that you can't animate in the browser, and you have to take care of that. And then Vue also has a transition group component, which is exactly the same like the transition one, but it's made for animating lists. With the transition one, you could only animate a single node, even if you could toggle between different nodes, but you could only have one at a time. With the transition group, you're going to animate a list of items. It exposes the same API. You can have the same hooks that the transition has, like before enter, leave, all that stuff. You can have the same name property to add the CSS classes to each one of these L items. But then it has two new properties. The first one is the tag. This is because in Vue 2 there is a limitation and the component can only render a single root node. And so this transition group component has to render something. It can't just render the 10 items you provide. It has to render them inside another node. With tag, you define which element you want to render. In this case, this is an ordered list. You could use a section, a div, or whatever you want here. Also, it's exposed a new move class. This is something that is really nice from Vue, because it animates when the list changes. So if right now I have some items ordered in some way, and because of user action, they change, you are going to, Vue is going to animate and move these elements. And it's going to do this using the move class prop. How does this work? This is the interesting part about the transition group. Vue does this using a technique that is called flip. It's a popular technique among the web. It's not related to Vue. I mean, you can implement this if you are using jQuery if you want, or vanilla JavaScript. This technique, what essentially does is animating an element between two states, an initial state, an initial position, and a final position. And let's say you want to move it from here to here. So this is the animation that the flip technique does. How does this work? Well, I'm going to use this CS3X article to explain you, because it's really visual. It's a technique that has 4 steps. So the first thing we do before animating, we want to animate this blue box. We want to change its position from here to out here. So the first thing we do is getting the initial dimensions of the box, the initial position and the initial size. We can do this using the getBoundingClientRect function. Then we move it to its final position, to the position it should be. And we retrieve again the new dimension, and we also store them. Once we have the first and the last position, we just have to subtract them. This is called invert. We subtract this data, and it's going to give us some delta value, some delta x, some delta y. And we are going to apply these values using a CSS style transform. So now this blue box is positioned inside the red square, but with the CSS transform property, we're moving it to the green square. Once we do that, we just have to play the animation. We just apply the transition style that we want, the duration, the delay, the easing, and we just let the animation play. And this technique is really great. It's really performant. First of all, it's using a transform, so it will run smoothly in every browser. And then it also avoids you to write code like request animation frame and having to calculate each single frame where the box or the elements that you want to animate should be. So it's really a nice way to write smooth animations. And this is implemented by Vue by default using the transition group. This is the technique that Vue uses. Well, with that, I will end you boring with this theory. I know some of you asked me for some links or where to keep learning about animations. Sarah Drafner is one really popular and really clever front-end developer. She's specializing into SVGs and animations, and she's part of the Vue core team. She also helps, I think she maintains the docs and that kind of stuff of the Vue project. She has well, lots of articles and workshops about animating and writing SVGs. I would encourage you to check her CodePen because she has lots of examples using the GSAP library that I told you. She's a really a great guru of the front-end development. And second, there is this properties. This is a Medium article that I think this is one of the best articles about animation that I have ever read about. And it explains you how animation should look in different cases. It has lots of information about the easing, the acceleration of the animations, and lots of examples and different cases. And with these years, that makes it really easy to understand what the article is trying to say. And then I have two blogs here, the Web Dev Blog and the CSS Tricks blog. You probably already know this website, and they sometimes post articles about web animation. For example, I get to know about the scroll linked new API thanks to a CSS Tricks article. So probably you should, if you want to keep learning, those are good sources of information. And finally, the last two, Hours and Dribble. These are both the websites that I like to use when I want to find inspiration, when I want to know how to do something. So Hours is just a website, a collection of different websites that are really that have a really great look, that looks really nice and maybe have animations. It has them organized in different sections. So you can check how other teams or companies do things. And Dribble is just like a social network where designers post designs, animations, and things like that. You can use just to create when you are creating a component for your project and you want to animate it a little bit, to bring it a little bit alive, you can use Dribble to find similar use cases. Indeed, we're going to use this in a couple of seconds. And now, well, we're going to move to the coding session. I want to show you a little bit of how I write animations using Vue and different techniques. Do you want to ask me anything about these slides? I'm going to share it after this meeting ends with you, in case you want to revisit them. So do you have any questions, something maybe you want to clarify? No? Okay, well, like one of my colleague says, silence is golden. So let's move on to do some coding. I'm going to change my screen. In case you want to follow, well, I'm going to share both the slides links and the repo links with you. Give me a second, because I don't know where the Zoom chat is, like always. These are the slides. And this is the repo that I'm going to use. You don't have to follow, just in case you want to take a look at it more slowly after this meeting. Okay, so I guess right now can you see my screen? Fine. Okay. Here, well, I created this small component. This is just a server because in Empathy we do search-related things, search-related stuff. So I think that a server might be a good example. And it isn't connected with any API, it's just a plain component with mock data in the front end. So when you type, this icon changes. And let's say that I'm bored and I want to animate this component a little bit to make it more playful. So the first thing I did was, do some research in Dribble. I found this animation, which is a great source of inspiration. This is what we are trying to replicate. I also found this little GIF in Dribble 2, which is the animation that we are going to try to write for the magnifying glass. So, let me drink, because I'm starting to feel my voice fading away. Let's check out what the code that we already have wrote looks like. We have a searchbox component. Obviously has an input. It's using the icon. We have a layer with a list of suggestions here. Okay, so let's start with something really simple to warm up. Let's add a hover transition whenever you hover one of these suggestions. Let's animate this a little bit. This is something really easy. So we can open the suggestion component, which is just a button with a category tag, a label, and an icon. These styles are already written. It's really nice. So we just have to focus on animating the hover effect. And here we can simply use the hover pseudo class. So we want, when we hover this element, this button, when we put our cursor over this button, we want it to change its background. So we just say background. I have a defined set of variables here in the app view. I will show it right now. And we can use the light highlight color, maybe. And as we want to animate this, we also have to add a simple transition here. We say that we want to animate the background color. We say that we want it to look like 250 milliseconds. And we want it to have an is-out is-in function. So now, whenever I hover these suggestions, we have this simple animation. This was quite easy to do, just 2 lines of code, and we have improved a little bit the experience already. As I told you, I'm using this. We are going to use these variables in this coding session. I like to define, when I'm writing styles, I like to define variables in a separate file like I'm doing here, and just reuse them across all the application just to have consistent styles. And that's what we are doing with the suggestion hover effect. Okay, then what else can we do? We're going to try to scale up the search box a little bit. Whenever you focus it, we're going to make it pop out a little bit. So we can go to the search box component, and we want to scale up this search box when the input inside has the focus. We already have stored the focus data. So whenever this input is focused, it will set this has focus variable to true, and whenever it's blurred, it's going to set the variable to false. Okay, so we just have to use this data. And to do so, we like to use a computer properties in my team. So we can create just a property called CSS classes. Don't worry, this is typed. I'm going to return a record string boolean, which is the type that is used for adding dynamic CSS classes. And here I'm going to return the object with a new class that is going to be search box. Has focus, and inside I'm going to use this. This is something not And related with animation, this is a technique that we use to animate things sometimes. And what we are doing, we're going to use this property for is we are going to tell Vue to you add the search box has focus CSS class whenever this variable has a truthy value. Okay, so we just created this property. We just have to use it. We go to the element and we say, we pass this as a prop to the div element. So we set class equals to CSS classes. And with that, whenever I focus the input, Vue is going to add this has focus class that we just added. And if this syntax looks unfamiliar to you, this is just a BEM. This is just a naming convention that we also use internally at Empathy. Just a way to that we have agreed to name CSS classes. So don't worry if you are curious about what the two dashes mean. It doesn't mean anything. Just a way to name things. Okay, so we're going to start adding here the transition again, like before. We're going to say, in this case, transform, which is the property that we're going to use for scaling. We're going to say 0.5 seconds. Let's use the isOutback. If you remember this from the Caesar website, this was the isIn function that bounces a little bit. It just feels really enjoyable. We are also going to define the transform here, scale, and we are going to scale it down a little bit, maybe 0.9. And whenever we apply this class, I'm going to add it here, maybe better. Focus. We're going to say to scale back to 100%. So I have messed something back, really bad.
It's in the computed property. I think you had a semicolon there.
Oops, yeah, well spotted. Thank you. Okay, let's recompile. Now, when we focus the search box, it pops out a little bit. Simple, also very simple animation. We haven't used any of the Vue features yet. So you don't have to be forced to use this transition or transition components. You can also add just the standard transitions. So next step, we're going to add a more complex animation, a collapse height animations. This is some kind of animation that you should try to avoid because we are going to play with the height of the element. As I told you, this will trigger all the rendering pipeline, all the three different phases, the layout, the paint, and the composite one. So it's really expensive to compute. Here it's going to look probably nice because I don't have lots of elements here. But well, sometimes designers design animations and you just have to make them work. This is kind of like real life. Okay, so where's the search box? We want to animate this section. Okay, we want to scale it down to collapse and to expand. So I have already created this component, collapse height, which we are going to use as the animation. As the section component already has a VI using the has focus property, this is already going to work. We just have to focus on implementing the collapse height and transition. Okay, so let's open it. We have a transition component that is going to receive the element that it has to transition using a default slot. And so we have to calculate the sizes of this element because in CSS you can't transition from 0 to auto height. You have to calculate and give concrete numbers so the browser engines can know which values it should interpolate. And to do so, we are going to use a mixture of both CSS classes and the JavaScript API. So this is going to be a little bit more complex, but I hope you can follow easily. Okay, so the first thing I'm going to do is I'm going to add the 3 methods that we are going to use. We're going to use a method called expand that is going to receive the HTML element that you are animating, and it isn't going to return anything. We're also going to add a collapse a function, and we are also going to add a cleanup styles function. Okay. Well, now it isn't compiling because of the ESLint rules. Don't worry about that. Okay, let's use them. We are going to say here, when enter, call the expand method. When leaving, call the collapse method. And both after enter, clean up the styles that we're going to add, and after leaving, clean up the styles too. We haven't implemented animation yet. This is just the boilerplate code, the empty placeholders. Okay, so let's try to write first expand animation. What we are going to do here is animate from 0 height to the height that the element has. So the first thing we can do is just say element.style.height equals to 0. With this, we are going to set the height of the element, and in this case, it is going to be the transition, the section element. We are setting it to 0. We are setting it to not have height. And then we are going to set it to have the height that it should have, the height of its content, which in this case, I don't know if you know this property, but we can use the scroll height property. What is going to happen when this animation is triggered is, first, initially we set the element to not have height at all, to have 0 height. Then, because we are using a property that implies reading the layout, the browser is going to apply this style immediately. And then it's going to apply this new style with the size that the element that it should have. Finally, well, we are going to combine this with classes, so the browser knows that these changes should be animated. Okay, the collapse animation is a little bit more complex. Well, it has another line. First, we're going to set the height of the element. Height equals to the same that we wrote here. We're going to set it to have a concrete height. Then we're going to force the browser to render this. We can use this with the element.getBoundingClientRect animation function. And then we are going to apply the 0 style like we did above. And with that, I think the animation code should be complete. We only have to be careful and write the cleanup style, because we don't want these styles to be there forever. So we just have to write element.style.remove property and the property that we want to remove, which is the height. Let me format the code so we don't see any warnings. Yeah, I think this should work. Probably it won't. But yeah, we have still pending to add the transition styles. And here we can just use this name, collapse height. And we're just going to add 2 classes for us. The first one is the enter active. And the second one is going to be the leave active. Here I'm just going to apply this style, so I can write transition height. The time that I want the transition to take, maybe 0.3 seconds is fine. and the easing function. And I'm going to use again the isOutBack. Then, well, I'm going to do the same here, but instead of isOutBack, I'm going to use the isInBack function. And if I didn't mess anything else, probably this, okay, something isn't working as it should. I told you I was going to mess this up. So let me check. Everything is fine. Okay, we have the beehive. We have the enter height. So I don't know what I'm doing wrong.
Javi, can you scroll up? That's a second. Just to
enter.
No, I'm checking the name of the transition.
You know, if I provided wrong names, it shouldn't compile at all.
Don't you have in the name of?
Zero is hey. Okay, let me cheat a little bit because I have this code written in my notes. I don't know what I have changed. Something weird is happening. Okay, I'm importing it. I'm using the default slot. I'm using the beehive.
Take a look to the console.
Yeah, I was sure it wasn't going to have any warnings. And the code is exactly the same now. So the problem must be here somewhere. Well, yeah, writing code is hard sometimes. Let me check. I didn't have any pending code here. This is weird. Okay, well, I have a second trick. So let me just move the branch and see what I did wrong.
Maybe if you start the server and run again, maybe, I don't know.
No, I don't think that would work. Thank you. Anyway, I think the next animation would be the transition. I have this code already written. Okay. Okay, here it works, and I don't know why. I see the code exactly equal. Let's focus. Okay, I would need to dig a little deeper into this. I don't know what I messed up, but I promise you the collapse height code is exactly the same. So probably I left in the Servox some pending code from the previous test that I was doing, but I don't know. Okay. Anyway, so sorry about that. Well, you can see the animation that we wrote, and it's quite nice effect, even if you shouldn't. I was using this height. Instead of the height, sometimes you can also use the clip path property. It's a CSS property that lets you kind of mask out the elements. But here, because I'm using a box shadow, that wouldn't work fine. It would remove the shadow, and the transition would end up looking really ugly. Okay, never mind. So let's try to write the next transition and see if I can make it work this time properly. We are going to animate each one of the suggestion elements appearing. So the spring style, shirt, dress, jeans, jacket, we're going to try to animate this. And we're going to use a similar approach than the collapse height component. So I've already created this pop-up transition. that we are going to use. Well, it's using a transition group here. So the first thing I'm going to do is use it inside the search box. It's going to replace the UL element that is already written here. So I just have to say up. As it is using a transition group, I have to provide it with a tag. So I'm going to say tag UL, an order list. Then I can go back to the pop-up file, and we can start implementing the code. What we are going to do here is, well, first we are going to implement a technique for view component that is called the transparent components, I believe. And this technique is useful when you don't want to rewrite all the props, because you just want to pass this prop from one parent component to a grandchild component. So you set this in any attributes to false. What this is going to do is that any props that this component does not recognize, it is going to it is not going to add them as a standard HTML attributes, which is the default view behavior. Here in this transition group element, we are going to bind this object, this attributes object, which is named $attributes. So every prop, like the tag one, that is not recognized by this component, you can see that here I don't have any props object. We are passing it explicitly to the transition group component. Yeah, okay. So with this, I think we can start writing the code of the animation. Something to notice is that because this CLI items doesn't have a PI directive, like it happens with the collapsed component, we have to tell Vue to animate the first time they appear. And we do that by using the appear prop of the transition group. So the first time this component appears, Vue is going to animate it. And what animation are we going to do? We are going to do a simple scale, like we did with the search box. So first of all, we add pop-up classes. We're going to add the active classes, the enter active. I'm going to say transition, the transform. I don't know, maybe 0.3 seconds, and use the bouncing is function, the is out back function. And we are going to do the same for the lift transition. But we are going to use the is in. And now we just have to write the style. How much should this element scale when they are animated? So we can add the enter class and the lift2 class, which will be the same ones. We just say here transform scale 1. So it's going to, whenever this element list element appears, it's going to have this style. This it's scaled to its own size. And we are going to reverse these classes. We're going to say enter2 and lift and set and scale down a little bit. So what we are doing, oops, so I did it. I set the wrong numbers. We want to, whenever the element is starting to enter, we want it to be scaled down a little bit. Like let's make it 0.5 so you can see it better. And we want to end up with a scale of 1. Because this is the default value of the transform property. I mean, each element has its own side. It doesn't have to scale it down or scale it up. You can remove these styles. You just have to provide this one. And if I save, and again, I didn't mess up anything like before, okay, you can see how these elements are scaled down a little bit. Because they are too wide, it looks like I'm only scaling up the X axis, but it's, trust me, it's doing it for both axes. But it doesn't look quite good. When I was writing the slide, I was telling you about the orchestration of the animation. So let's try to do a little bit of orchestration here. Let's say that we want each one of these elements to appear a little bit after the one before. So there are many ways to do this, but I'm going to use the technique that the view docs suggest using it. And this is going to be using a data index property. So I'm going to add to each one of these LI items a new data index property, and that is going to be well, the index they have in the list. Okay. Then I'm going to retrieve this data index property within the animation. I'm going to create here a set delay method that will receive the element. I'm going to apply these delay styles. Okay. So first of all, well, I have to calculate these styles. I'm going to create first the index. I can do this by using the element dataset dot index function, and I'm going to transform this into a number. Because this property can't be defined, I have to provide a default value. I'm going to use using the null is while extending operator. This is a new JavaScript operator that will only execute the right-hand side if the left side, which is this one, is null or undefined. Here I will set 0. Okay. Then with this index, I'm going to calculate the delay of each element. This is called the staggering. So first of all, because I don't like to hard code numbers in my components, I'm going to implement this using a prop. We can add the stagger milliseconds property. We can set it to be of type number, and we can set it to have a default value of 35 milliseconds maybe. Then I'm going to use this property to calculate the delay of each element. So we can simply do this dot stagger seconds multiplied by the index. Okay. And I'm also going to add a new property because when you want to orchestrate things should happen after each other. So I'm going to add a base delay to this component. And I'm going to set it like the one below to be of type number and to have a default value of 0. And then I just have to add this new prop here. Is delay plus the staggering that we are calculating. And finally, I just have to apply the styles to the element, and maybe element dot style dot transition delay equals to a delay in milliseconds. And finally, we are going to add another function like with the previous component to clean up these styles. And it's going to have the same shape like the one above. And I'm going to say element dot style dot transition delay, dot style dot remove property transition delay. Then I just have to use these new functions here in the hooks. So we can use maybe the before the hook. We set the delay of the element before leave, we can also use this set delay function, and we will invoke the cleanup one after enter and after leaving. And then we are also going to add a small base delay to these elements. So we can, let's say here, base delay, maybe 100 milliseconds, yeah, so it's kind of overlaps with the previous animation a little bit, but it waits this 100 milliseconds before starting to play. And again, well, let me reduce a little bit the scale down because it's too much. And close the dev tool so we don't have this overhead. You can see this nice effect that each element is entering a little bit after the one before. Again, everything in website is about orchestrating, and this is a nice effect that we like to use in our components. And finally, we will write the most difficult animation. We want to, let's say we want to animate the search icon like this GIF here. So like this, when you start typing, we want the handle of the magnifying glass to transform into these 3 dots and start the spinning. This is a little bit more complex like the ones below, but it's kind of easy to implement. So first of all, I'm going to zoom in so you can see it properly. And let's see what we have right now. As soon as I type, it doesn't do anything. It just transforms the handle of the magnifying glass into these 3 dots. And how does this happen? Well, the search box has, whenever I type, it invokes a method that is called fake search that is going to set its loading property to true for a couple of seconds. Then we use this loading function inside the search icon component. We just pass it here. So if we go back to the search icon component, you can see that I'm using inside an SVG. You can write SVG code with your view components, and indeed it's a really nice way to animate things. So I'm toggling between these 3 dots, which is the ones that appear while the input is loading. And this line is the handle of the magnifying glass. So yeah, first of all, let's add a transition here because we want the change between these 2 nodes to be transitioned, to be interpolated. And let's call this transition maybe search loading. So how are we going to animate the movement of the handle? Well, if you see here, this handle is defined using the stroke property. The stroke property is the SVG equivalent to the CSS borders. But they are more powerful. SVGs allow you to provide a dash array, which can be used to create dashes or dotted lines. So here I have defined the line to be this width and to have a blank space of 15 pixels. So then with a stroke dash offset property, I can animate this movement. Okay, so let's say let's add it here. Handle whenever it is also loading. We can have here a search loading class, and we're going to add the active properties, which should be enter active transition is throw dash set. I hope I typed it right. Maybe 0.25 seconds, and is out. And we're going to do the same for the leaf transition, but instead of is out, is in. So now we just have to write what are the values that should be interpolated, and I can do that by just adding the enter leaf 2 and enter classes. We could say to have a struct dash offset of minus 14 pixels, which is just 1 pixel below this number. And again, I have lots of risks here writing this animation in live. So let me check. I think I'm not missing anything so far. So, but then yeah, I'm missing something. So we're animating the handle whenever it's loading. We want to move it 14 pixels back. Okay.
Do you have to add a dash after the name, because previously you were adding it? No, there in the transition. Where? In the transition.
Oops. Well spotted. Yeah, the event naming convention. Thank you. Yeah, perfectly. Thank you once again. Risk of coding live. Okay, so now you can see how it moves a little bit, but the 3 dots appear immediately. As we learned before, we can change this to use the out in transition, but here we will find another problem. The problem is that Vue knows when you are animating the child nodes. If I was going to animate this group, Vue will know how much time the animation will take. But what I want to animate here is these 3 bubbles, these 3 circles. And Vue can know that. There is no way, unless it starts iterating over each single element on the website. So I have also to provide a duration here to animation. This is a dirty trick, but it should be fine for this demo. With this prop, I'm telling to Vue that the animations that is going to run thanks to this component are going to last half a second. It's a milliseconds time. And so now let's well, first of all, let's animate this spinner. We want it to rotate, so we can just do here spinner, and we can write an animation. We are going to call this animation rotate. We want it to take like a second to complete. We're going to say it to be infinite and to have is in out is in function. So now, how do we write this animation with the keyframes object? It's going to be pretty easy. Oops. We are going to call it rotate, like here. And we can just say animate from rotate 0 degrees to 360 degrees. So just turn the element around. Because again, having a 0 degrees rotation is the default, you don't even have to provide this from. Okay, so now this animation, the spinner, whenever it appears, it should start rotating. You can see it. And the last step is going back and animate the bubbles, each one of these circles. To do so, we have to create a slightly more complex CSS selector. So we can type here again, start loading, Here, I think I'm going to have to add again this interactive and live classes. But I want to animate each one of the circles independently. I want the left circle to move to the right and the right circle to move to the left. So, okay, yeah, the first thing I'm going to do is just adding the active ones, which are the most simple to write. I can even copy and paste from here. And just tell that this should be done for the bubbles, which is the class that I used here all for the circles. So I just have to write search icon underscore spinner bubble. And I have to do the same, but for the enter and leave to classes. So yeah, let's go on. Because I'm too lazy, I'm going to copy again this block. And we have to use here pseudo class to select the first circle and the third one. This pseudo class would be the nth child. So again, I can write this here and here. And inside of this block, I'm going to use the child, the first one. This is not zero indexes like arrays. This is the first element is the first one, and the second one is the second one. No, it doesn't. It isn't zero indexes like arrays. And I'm going to move this element to the right by 4 pixels, if I remember correctly. Oops, sorry, translate X. And I'm going to do the same for the third element, but instead of moving it to the right, I'm going to move it to the left. Yeah, I think again I will probably have messed up again the styles, but let's check. Okay, I messed up the styles. I told you these selectors were a little more complex. So let's see what is happening here for the spinner. Whenever it's loading, I set the oops, yeah, this shouldn't be a stroke dash offset. This should be transform. Okay, and it's done. So I don't know how good it looks in Zoom, but in my screen at least it looks quite nice. Yeah, with all these simple animations and micro interactions, the only thing I wanted to show is that in a couple of, I don't know how much time it took me, maybe half an hour. I think I have created a much funnier search box component to use. So I don't know what you think of, but this is the end of my presentation. This is all I wanted to show you. I don't know. Do you have any questions? Something you want me to clarify to explore more in detail? Again, this code is uploaded in the repo in the master branch. Probably not exactly equal like the one I just wrote, but yeah, it works the same way. So you can have time later to check it out if you want, if you are more interested into this animations field.
I have one question. Referring back to the last session with the reactive design and all this stuff, I wanted to know, how do you adapt the animations to different sizes of a screen? For example, you right now use a lot of pixels, I guess, for simplicity. But how do you exactly adapt those things to, for example, to a smartphone and then to a desktop computer?
Well, depending on the on the device, you could use different units. Honestly, this isn't something I never had to deal a lot with. I mean, solving animations problems on different screen sizes. But I guess you could simply use other units. For example, instead of plain pixel, it might be better to use EM units, the units that are referred to the font size, because in fonts, usually people change the length of the font, the size of the font. So maybe if you are running into these problems, you could try to use a different unit. And yeah, I mean, every specific problem that you have with sizes would have a root case, and I guess you would have to find a different solution for each case. The most simple one, I would say, is to use other units. Also, well, related with this component, that won't be a problem because as we are working with SVGs, these pixels refer to the SVG viewbox. I don't know how much you know about SVGs, but essentially we are creating here a kind of like a virtual screen that is 24 pixels wide and 24 pixels tall. So when I'm moving here 4 pixels, I'm referring into these units. Even if then this SVG ends up having 100 pixels of size, because you do that with CSS, but virtually internally for working with animations and positioning elements like this one, you have to always deal with these units. So that won't be a problem. Does that make sense to you, or?
Yeah. So yeah, essentially working with SVGs helps a lot with that kind of stuff. Another question, I saw that you used, for example, new components exclusively for the animations. Do you usually do that here in Empathy?
Indeed, in the X Components project, we have created a system that completely separates components from animations. So we have different components like this pop-up or this collapsate. Indeed, this collapsate is exactly the same code that we have at the X Components project. And then when you are using other component like the search box, a list of suggestions, or a list of results, you have a special prop that we have called animation. And there you pass the name of the animation or the animation component itself. So yeah, you just have to write this animations code once, and you can reuse it across all the components that you have.